Today we're talking about graph of sin x, cos x, tan x, and their transformations. Okay. Let's take a look at the most basic form of graph of sin x. And let's say x is between 0 to 360 degrees. So you must have this shape memorized. You have 0 here, you have 360-degree here, in between you have 90, 180, 270, and 360 degrees. So the graph looks like this. And this would be 1, and the minimum value would be minus. You must know that the graph does go beyond this and repeats the cycle every 360 degrees. So this would be 720 and so on. And similarly, it goes towards the negative side as well. So the cycle keeps repeating itself after every 360 degrees. That's why the period of sin x is 360. The periodicity or period of this graph is 360 degrees. Okay. Now, let's talk about the graph for y equals minus sin x. Now, if you remember from transformation that when fx becomes negative fx, it's actually a reflection on the x-axis.
Assalamualaikum.
Walaikum assalam. So minus sin x is the reflection of the first graph. It's going to look like this. Between 0 and 360 degrees. So again, you have 1 here and minus 1 here, and the x, the markings on the x coordinates are the same between 0 to 360. So you have a 0 here and 360 degree here and 90-degree divisions in between. Okay, so what minus sin x is, it's a reflected graph of sin x on the x-axis. Another thing, you might be asked to plot everything in radians. So then this is 0. 90 is pi by 2. 180 is pi. 270 is 3 pi by 2. And 360 is 2 pi. So it depends whether the question is in degrees or radians, you have to plot accordingly. Okay. So the period of this graph minus sin x is still the same. It's the one cycle finishes between 0 to 360 degrees. So the period is still the same. Period for this one is still 360 or 2 pi in radians. Okay. Now, let's talk about sin x. Okay, let's talk about 3 sin x. So what if you have y equals 3 sin x? So if you remember when we were studying transformations, if fx changes into 3fx, it's a stretch parallel to the y-axis with scale factor 3. Stretch parallel to y-axis, and the scale factor is 3. So what happens that this graph stretches along the y-axis with scale factor 3. So nothing happens at the x end, and the graph just becomes taller. This is a bad attempt at sine graph. Let me try again. So the graph would now be like this. It goes till 3 and it goes down till -3. So this would be the range is between 3 and -3, and the x values are still the same: 0, 90, 180, 270, and 360. And the period is still the same. Period is 360 or 2 pi. Okay. Now let's discuss the graph of sine x plus 2. Y equals sine x plus 2. So if you remember, when fx transforms into fx plus 2, fx plus 2, that is a
Translation.
transformation. Translation. Yes. Translation by, it's just going up. So it's 0 to. So what you do to the sine graph, you move it 2 units up. Got that here. So we have an x-axis, we have a y-axis. On the x-axis, you have 0, 90, 180, 270, and 360. But now the original graph goes 2 units up. So if this goes 2 units up, this central line, which was 0 at the initially, this is 0, it also goes 2 units up. So you have to plot a new central line. This gives more clarity to the concept. So now you draw sine x graph around this point. So you may translate these points on the new central line. ये जो है, इनको यहाँ dotted बना लो, so then you get a pretty symmetrical graph. And then this goes 1 unit up and 1 unit down because the magnitude of the sine's graph is 1 unit. So you have a graph between 1, 2, 3. So now your range of the function is between 1 and 3. And the central line is 2. So that is what the graph looks like for sine x plus 2. Okay. Period is still 360 or 2 pi, because one cycle is completing between 360, between 0 to 360 degrees. Okay. Now let's sketch the graph for y equals a minus 2 sine x plus 5. Okay, now a lot of transformations are acting simultaneously. First of all, this is not going to be a graph of sine x, but minus sine x. So what is the shape of minus sine x? Let's just roughly sketch it. It's a reflected graph on the x-axis, so that's minus sine x. Secondly, it's not just minus 1 sine x, it's minus 2 sine x. So now the magnitude of the graph is 2, so the height goes till 2 and minus 2. But then this graph is also being moved 5 units up. So I have to draw the same thing, but 5 units up. Let me do that. The new central line is at 5. Let me draw a dotted line here at 5. Half of the graph would be above this, and half of the graph would be below this. Similarly, I have a 90 here, which I'll project here with a dot. So 180 here, dot. 270 here, बस थोड़ा सा रह गया 360 here. Okay. So we get a graph like this. And remember the magnitude is 2. So it goes till 7 and this goes till 3. Again, the period of the graph did not change. It is between, it's 360 degree or 2 pi the period, but the range is now between 3 to 7. Like खाने के बाद क्या करा? Okay. Next is the graph for sine 2x. I'm getting internet connection unstable continuously. I hope you guys can hear me. Do I need to fix something at my end? या मेरी आवाज आ रही है?
सही आ रही है।
All right, ठीक है. अच्छा जी, moving on to the graph of sine 2x. Okay. Now, if you remember from transformations that when fx changes into f2x, then this is a stretch parallel to x-axis. And the scale factor is actually the reciprocal of 2, but scale factor half. So actually it's shrinking along the x-axis. So let's just take a look. Original sine x looks like this. Between 1 and minus 1. This is the original sine x, 1 and minus 1. And we have 360 here. Okay. Now let's shrink this along the x-axis. Squeeze ho jayega because this its scale factor is half. So now, instead of the graph completing its full cycle at 360 degree, it's going to complete its full cycle at 180 degree. So this is the new graph, one cycle of the new graph. And if you're asked to plot beyond it, then it keeps going on. So now the period has changed. The period of this graph is 180 degree or pi by 2 in radian or pi in radian. Sorry, not pi by 2. ठीक है? एक और जो जिस तरह मैं याद रखती हूँ, since this is 2, so the graph completes 2 cycles in with 360 degrees instead of 1 cycle. So the first cycle gets completed at 180 degree and the second cycle gets completed in 180 degree. So that's how I remember the shape. Mostly you're being asked to plot it between 0 to 180 degree. So you must remember that you have to plot a complete cycle between 0 to 180. Okay. While we're at it, let's also discuss the graph for sine half x. Okay, I got disconnected. Back now. Loading. We're back. Okay. So now we're plotting the graph for sine half x. Okay, again, when fx transforms into f half x, then it's a stretch parallel to x-axis. Stretch की spelling में ख्याल में गलत लिखी है. Stretch parallel to the x-axis with scale factor, take the reciprocal of half 2. So the original sine graph looks like this, which completes one cycle between 0 to 360 degree. This one will complete half a cycle between 0 to 360 degrees. So what the graph should look like is that you just show one of the mountains or one of the half of the curve between 0 to 360 degree My screen is stuck. Why am I not surprised? Just give me a second. Okay. Yes. So just half a cycle between 0 to 360 degree. And if you have to draw one complete cycle, then it goes till 720 degree. And hence the period of this graph is 720 degrees in radian in degrees and 2 pi radians. That's the graph for sine half x. Okay, I think, yes, now we're left with sine square x. Okay, last graph we need to know for sine is sine square x. This you must remember is an M type shape. जैसे वो मैकडॉनल्ड का लोगो होता है ना, इस तरह का लोगो. So this is 0. This is midway 180. That's one cycle 360, and then that's 90, and that's 270. So a very smooth M. This kind of very symmetrical M, like this. And this is
Is it
one.
because negative भी positive हो जाता है?
Yes, exactly. But it's not exactly like this. If you take it too literally, then it looks like this, but it's not. It's like a gradual increase. It's like this. All right, I think we've discussed all the cases of sine x graph. Let's now come to cos x. So I'm going to give you guys the basic shape of cos x graph, and then I'm going to ask you to try and draw the transformations yourself. So you must know that cos x in its most basic form between 0 to 360 degree looks like this. That's one complete cycle of cos x or cos theta. This is 1, and that's -1. And this is 360 degrees, and that's 180 degrees. And in between, we have a 90 here, and we have a 270 here. And if you're in radians, then you must know that 90 is pi by 2. 180 is pi, 270 is 3 pi by 2, and 360 is 2 pi. And hence, period of cos x is 360 degree or pi. Or pi radians. All right. Keep this in mind and give me the graph for minus 2 cos x, 3 cos x plus 5 cos 2x cos half x cos square x. These are all the transformations. This one would be, it's minus cos x, so you have to reflect this graph on the x-axis. So now it looks like this. It's opposite, or it's reflected, but the magnitude is now 2. So where it was 1 initially, now it's 2. And where it was -1 initially, it's now minus. And that's 360 degree. So the period is still 360 degree. One complete cycle is ends at 360 degrees, starts at 0.
Miss, I don't understand why it was reversed.
Because just like cos x when just like sin x was like this, but minus sin x.
Okay, miss. So if it was positive 2 cos x, then it would have still remained the same, right?
Yes. Minus sin x is a reflection of sin x on the x-axis. क्योंकि हमने transformations में पढ़ा है that when fx becomes minus fx, it reflects on the x-axis. Bring on to 3 cos x plus 5. Okay, now what happens? Cos x graph becomes larger. Its magnitude becomes 3. But it also goes 5 units up. So move the central line first. The central line is initially this 0. But now it's going to be 5. New central line helps to make that first. Now this would be 90, 180, 270, 360. Let's project these on the new central line. Okay. Draw the cost graph here, but remember that the magnitude is 3. So the max this graph goes till is 5, 6, 7, 8. 3 units above 5 here. And minimum value would be 2. 3 units below 5. Okay, and now we draw a cost graph. It's like this. Do a better job at it. इस तरह. अभी भी इतना अच्छा नहीं बना. Better. So that's the graph for 3 cos x plus 5. The period is still 360 degree or 2 pi since one cycle is completed at 360 degree. Cos 2x. Cos 2x means now 2 cycles will be completed in 360 degrees. So one cycle is completed within 180 degrees. So the graph looks like this. It's a typical cos graph, but you ended at it's like this. Okay, so it ends at 180. And if we're asked to go beyond it, then the second cycle is completed at 360 degrees. So it actually shrinks, but you still call it a stretch, but the scale factor is half. So this is the first cycle, and the other one is the second cycle, which you might or might not be asked to show. Okay. Ryan, did you raise hand? Yes. So
Yes, miss. Miss, I just wanted to ask, could you please review the graph of 3 cos x plus 5 once again? I'm a bit confused about it.
The graph goes 5 units up. So we move the central line 5 units up. Usually the central line of sine and cos is this x-axis. But since it's plus 5,
0. Yes, miss.
5 units up. अब इस पे cos x का ग्राफ बनना है, ठीक है? But cos x का नहीं बनना, 3 cos x का बनना है.
Cos x.
इसलिए ना
So
हमने
that's why it's 8.
magnitude 3 रखा है. Yes, so it goes till 8. And below that, it also goes 3 units down, so it goes till 2. So the range of
and miss, if this was to be negative, then the graph would be
upside
flipped, right?
हाँ, फिर ऐसा होता है, क्यों करके.
All right.
It would have been
Thank you,
negative
miss.
3 cos x उल्टा हो गया और 5 units ऊपर चला. Okay, so then we discussed cos half x, cos 2x, sorry. Now let's discuss cos half x. So half x means now half a cycle gets completed between 0 to 360 degree. So here's 360 degree. I know a full complete cos cycle looks like this, and half of cos cycle looks like this. So I have to just draw half of the cycle. So it goes like this. This is 1 and this is minus 1. And if you're asked to finish it completely, then it goes till 720. Now the period of this graph is 720 because it completes one complete cycle at 720. And for the previous case, this one, the period was 180. Okay. Similarly, for cos square x, you need to remember that it's a W shape. So it looks like this. Instead of an M, it's now a W. So this is 1. That's 0 because now it's squared. So you won't have a minus 1 here. You will just have a 0 and 1 as the extreme values, and in between you have 180. At the end you have 360, and then 90 and 270 in between these. 90 here shouldn't go below the x-axis. Mine has slightly gone below it, yours shouldn't. And this is 270. These are all the transformations you're expected to know for cos. Now let's talk about tan.
हमें ये याद होनी चाहिए
बिल्कुल कोई भी आ जाएगा कि इसको स्केच करो या इसको स्केच करो या इसको स्केच, बिल्कुल याद होनी चाहिए, सिलेबस का पार्ट है. Now let's discuss tan x. Y equals tan x. Tan is quite different than sine and cos. 0, 90, 180, 270, 360 degree. Remember the period of tan from last lesson. Period of sine and cos is 360, but period of tan is
180.
180, yes. So original period of tan x is 180 degree or pi radians. Okay. Next thing you need to know that if you find tan 90 in your calculator, you get math error. So you show that using an asymptote here. Similarly, if you find tan 270, your calculator will say math error. So you draw an asymptote, a dotted vertical line at 270 degrees. That means there's no value of the graph of tan x at these values of x, 90 and 270. Oh. Then tan 0 is 0. So you have a 0 here, and then the line goes like this. It shoots up like this, but it must never touch the asymptote. Don't let it touch. It will go as close as possible to the asymptote. In fact, this distance will keep decreasing as it goes up, but these lines can never meet. And then the second part of the curve goes up from this end, and it's like this. Again, as you go down, the distance between the curve and the asymptote keeps decreasing, but again, they can never meet. This is one complete cycle of the tan x graph. After that, it repeats itself. So the rest of it is like this. Keeps repeating. All right. So that's the basic form of tan x graph. One thing you need to know here is that here you have 45, and you must remember that tan 45 is 1. So you have a 1 here. And similarly, in between these, you have -1. यहाँ कहीं -1 से cross करना चाहिए था, इतना अच्छा हुआ नहीं. But I hope you get the idea that this is 135. Another 45 degrees beyond 90, you get a minus. Not that you're asked to show this, but this might come in handy when you're asked to plot a graph for 3 tan x. So when it stretches by scale factor 3, all you have to do is with 45, now you write 3. And with 135, now you write -3 because it has stretched. So that's the only way you'll show that you've plotted 3 tan x. Otherwise, the shape of the graph looks the same. Since it's an infinite graph, so the scale depends what scale you use. So if you're asked to draw 3 tan x, it also looks pretty much the same. उसी तरह का graph होता है. However, now here in between, you'll have 3. And here you'll have -3. So that's the significance of knowing that tan 45 is 3. Okay. Similarly, if you have to plot tan x plus 1, then it goes 1 unit up. So you move the central line. Let's plot tan x plus 5. I'm just going to plot one cycle, not 2 cycles. So we have 90 here, which will have an asymptote, and 180 here. Central line has gone 5 units up, so I'm going to plot a dotted line here. This would be 5. So the graph is like this and like this. This is tan x plus 45. And in between, at 45, this would 1 unit, so this would be 6. And in between 90 and 180, at 135, this would be 1 unit below, so 4. Not that you're expected to show this. ये नहीं show करना. This is just a reinforcement of what we just discussed. Okay. Now let's talk about tan 2x. So now what happens that the original period of tan x graph is 180. One cycle is completed within 180 degrees. But now 2 cycles will be completed within 180 degrees. So one cycle is being completed between 90 degrees. So either पूरी tan की one cycle complete हो जाएगी. It was going like this, and then you'll have an asymptote in between. So this would be 45. You have an asymptote at 45 for tan 2x. And if you're asked to plot the rest of it, then it goes till 180. 2 cycles are being completed within 180 degrees. So the period of this graph is 90 degrees or pi by 2. Similarly, let's plot tan half x. For this one, half a cycle is completed between 0 to 180 degrees. So one complete cycle of tan looks like this. So half would look like this. So the asymptote would be at 180 degrees. This is half the cycle. So half cycle is being completed at 180 degrees. That means full cycle gets completed at 360 degrees. So the period is 360 degrees. tan square का ग्राफ नहीं है सिलेबस में, thank God. I'm going to leave you guys with two
मिस
questions.
अगर नेगेटिव tan आ जाए
हाँ, thank you for reminding. बिल्कुल negative tan तो है सिलेबस. So negative tan में क्या होता है? Let me just draw tan again. Tan x is like this. This is one cycle, and there's an asymptote here at 90. If it is negative tan x, what do we know about negative effects? Reflect हो जाता है on the x-axis. So now that part gets reflected and this part gets reflected. So it becomes like this. So reflection on the x-axis. Understood?
मिस ये 360 तक नहीं बनेगा ग्राफ
tan का पीरियड 180 होता है ना, अगर आपने
ओके
360 तक बनाना है तो आप सेकंड साइकिल दिखा रहे हो तो बीच दिखा देते हैं, नॉट एन इश्यू. यूजली ना आपसे इस सिंगल साइकिल ही प्लॉट करवाते हैं, बट यू नेवर नो, कॉन्सेप्ट के लिए तो आपको सब कुछ पता होना चाहिए. So if we take it till 360, so it will be something like this. Another asymptote here, and then another curve here, S out. So everything got reflected on the x-axis. That's all from my end today. If you have any questions, please ask. Please, इसको ना आज एक दफा दोबारा सारा देख के आना कल के लेसन के लिए. This is your homework for today. Go over today's lesson. Then I'll see you tomorrow, inshallah. Take care. Allah Hafiz.
अल्लाह
अल्लाह हाफिज़ मिस